All right. Good evening. We are here for Work It Out Wednesday. We started a little later tonight. We actually had a webinar earlier today. And if you are a teacher or educator, please join us for our webinars. We're talking about all things that are happening in the classroom. I am going to get started with our first request of the night, which is subtraction using the number line. And I have one of my favorite tools that I got at Lakeshore Learning. It's just a little erasable board that you can use with your students anytime. And we're going to use it to make our quick number lines and counting for sure. Um, I did some subtraction with a student today as well. And so while I'm doing this, I'm absolutely going to be talking about some of the misconceptions that can come up and just how your students should be thinking about these subtraction problems and things as they are doing it. And if you have any math requests tonight, drop them in the chat. I have some help in the chat that will be making sure that I see your problems and know what you need support with. And as always, we are so glad that you are here with us this evening, and we are going to jump right in. So I am going to start, and I'm going to put the problem down below just so we can see it. And we're going to do 82 minus 31. And what does it equal? So one thing, when using the number line, here it says 0 and 1, but those don't matter. You can have your students. I tell my students, let's start with our big number. So we're going to put our 82 here. And then I ask them, how many do we have in our tens place? And so I make sure they can identify. And so since we say we have 3 tens, that means we have 3 big jumps of 10. And so we're going to put our 10 here, here, and here. And so now we're going to have our students to subtract by 10 from that big number, because I remind them we're trying to get smaller, right? Because we're taking away and breaking apart that 31. So 10 minus 82 gives us 72. 10 minus 72 gives us 62. We take 10 from 62, we get 52. Now we go to our ones place. How many ones do we have? We have 1. And then we do the same thing. We subtract by 1, we get 51. So this absolutely can help your students to visually see how to do subtraction using the number line. And especially when you have students who they're just getting comfortable with subtraction, this is such a great way. And so I'm also going to show one where there is a little regrouping too. I'm just looking for something to erase my board. I guess I'm going to use this here. If anyone has any questions, drop it in the chat for me. I would love to hear all about it. And on this next problem, I'm actually going to do it the opposite direction as well. So we are going to do 63 minus 45. And so this time I want to start on this end. I'm going to make this 63. We're going to actually tell our students we're counting down, and even reminding them our number lines can go left to right when we're reading them, when we're actually using the number line properly. And the same way we did the first one, I always want to ask ourselves, what's in our tens place? Well, we have 4. So that is 4 humps of 10. 1, 2, 3, 4. We're going to put our tens here to remind us what we are subtracting by. And if you want to add that subtraction sign, you can. I know a lot of our students have some handwritings that aren't great. So, I limit what they write. Oh, thank you so much for tuning in. Let us know if you have any problems you want us to work out tonight. I'm just getting started. Somebody has requested equations, slopes, inequalities. We're going to be doing some big things tonight. Okay. So as we continue, so we're subtracting that 10. We know we're going to 53, 43, 33, and 23. And then we go back again to our ones place and we have 5. And I still do 1, 2, 3, 4, 5. And so we're going to put our ones and we're going to count that down. And you know, one thing about this, you want your students to count it down because a lot of our students are just not comfortable counting down sometimes. Like we're really great at counting up, but not so much at counting down. So this is also a great way for them to see how all of our numbers are connecting for sure. And so we have 1, 2, 3, 4, 5. What did I do? I did something here. Oh, yes. I'm over here like, what did I do wrong? That's 18. Alrighty. I absolutely was like, that is not 20 that I was about to totally write there. But that's because I wrote the wrong thing with counting. I was talking too much. So we get 18. And this is how we can use a number line for subtraction and getting our students just really comfortable with what is happening in subtraction. Yes, kids absolutely make mistakes every day. Yes. And I actually tell my students that is where we do the most learning. We learn from our mistakes. We really don't learn from always getting everything right, actually. So, okay, somebody said, oh, ooh, some algebra is coming up. Yes, it is. So let's jump right in. For some reason, solving for equations has just really been a hot topic. Like every week, everybody wants us to solve equations. So I am going to just jump right in to solving some linear equations tonight. And I'm going to tackle one that we all love. We get some of the most questions about. And if you've been here, you've probably seen me work out something similar before. All righty. So everybody gets a little nervous when they see this fraction of 4x minus 6 over 5 and seeing that 5 in our denominator. It really tricks students up, whether it's an x or whether it is just a number. But what's really happening there, we are dividing. And we always have to remember our goal. Our goal is to get this x by itself here. We're solving for that x. We're isolating it. We want it to be all by itself. So the first thing we're going to do, since this 5 is dividing, we're going to multiply by 5 on both sides. And I'm going to switch some colors. So we get 10. And then since this is 5, it's really a 5 over 1. And so that gives us 5 and 5. So they're just going to cancel, and it really leaves us our 4x minus 6. So now it's back to a regular equation. And so we are going to solve this like we normally do. We're still isolating that variable. So we're going to add 6 to both sides because we want to do the opposite. And really what's happening is these cancel out to equal 0. That's what you're really doing. And so we get 4x equals 16. And then we are going to divide, and let me move my paper up for you. We're going to divide by 4 on both sides. So we get x equals 4 for here. So even though it looks intimidating, it is not as intimidating as we think. Alrighty, so we have a request for slope tonight. We absolutely will. So tell me more on this slope. Do you want me to do some y equals mx plus b, or like an equation that's slope-intercept form, and I need to make it into the y mx plus b form. I know I'm asking a whole lot, and I'm sure Kimberly is like, what are you doing? But you know what? I'm gonna get you something. I'm gonna put something together real quick for you. Okay. I have something for you. Do them all. Oh, okay. It's gonna be a long, fun night tonight, huh? Okay, so first, what is our slope intercept form? Well, that is y equals mx plus b. And what this stands for, m is our slope of the line, and b is our y intercept. Okay, and if we really go there, this is really a great setup, or what helps us graph these equations. All these equations that we work on, we actually can turn into graphs. And I might do a little something tonight too. So I'm going to start with a real simple one, and then we'll build up from there. So let's go with this one here. 10x minus 12y is equal to -4. Alrighty, so the goal is always to get it in this form, meaning we want y by itself, because we want to make sure that we understand what our intercept is, especially if we're trying to graph it. So we need to first recognize what's all happening to y. Well, we see 10x is subtracting and it's being multiplied by 12y. So that's where it comes to play that you're really solving it like an equation. So we're going to subtract 10x from both sides. And again, these cancel out to be 0, and that's why we do the opposite. So we are left with minus 12y is equal to negative 10x minus 4. And now this is multiplying, so we got to do the opposite. So we're going to divide both sides by negative 12. And so now we get y is equal to, and since we have a negative and negative, we can make it 10/12 x. And we have a negative and a negative, so it'll be a positive. And I'll go ahead and reduce. So it'll be 1/3 for there. And then we can also reduce this 10/2 because they're both even. So that's really 5/6x plus 1/3. So y equals 5/6x plus 1/3. So I'm sorry if you can't see it. Our slope will be the 5/6, and our y-intercept will be 1/3 for this problem. And so if I actually made a quick little graph over here, and this is our y-axis, our x-axis, and I'm just doing something real simple. Our y-intercept is when x is 0. So when x is 0, and we said 1/3, so let's say maybe it's about here, especially if I said 1 was here. And then we would take our 5/6 and we would go 5 up, 6 over, because we do, for slope, m is equal to rise over run. And a great way that I tell my students this, when you rise, think about standing up. When you run, think about like you're running across. So our 5 means we're going to go up by 5. And you only need 2 points on a graph to really draw a line. And so since we know our y-intercept, I'm just going to start from there. And again, this is just a quick graph, so don't hold me for the technicalities here. So let's say we go 1, 2, 3, 4, 5, and then we'll run over 6. 1, 2, 3, 4, 5, 6. So say our graph went like this for this line. And because it's a positive, it's headed in the positive direction. Just some food for thought. And was this what the request was? Would you like to see more? Okay. All right, I'm going to do another one for us. And we're going to, oh, that I see asked about a lot is when given 2 points creating the equation. Okay, yes, we can absolutely do that when we're given 2 points. So that is actually called point slope. We can do some of those too. Let me get us something. I'm going to do one more this way, and then I will come back and do a point slope one as well. So this is just becoming algebra night here. 12y is equal to 8x minus 48 divided by 3. And we always want to remember our goal is to get y equals mx plus b. I'm going to put that here. Bring on the algebra. I bet. All righty. And so like our first one tonight, we want to multiply both of these sides up. Wait. We don't even have to. We can. Okay. I'm going to do a little switcheroo. Okay. So I just want to get this 3 from being a divisor here. So 3 times 12, we'll get 36y is equal to 8x minus 48. And since we're looking to get it in y equals mx plus b, we want to just get y alone. So we can divide both of our sides by 36. And then we are going to simplify or reduce. What is 1/3? Okay, I see a question in the chat from our last problem. I will go back. What does the 1/3 do? Well, the 1/3 is your y-intercept. Because if you notice, we have our problem back as y equals mx plus b. So the 1/3 is your y-intercept, which is a point on the graph. So you would be able to graph 0, 1/3. And if you want to, you can change that into a decimal, which is like 0.33. So that would be your y-intercept. And that would be where it would be on the graph. Let me know if you understand that or if you need me to come back to explain that. And I'll show it in this problem too. So as we continue with this one, it's in our y-intercept form now. So we would like to simplify or reduce to its lowest terms just to make it easier to graph and things like that. So if you caught our Instagram, I have been simplifying using prime factorization. However, we will not be doing that tonight, but if you want to check that out on how you do that, you absolutely can. 8 and 36 are both even numbers, so something fast you can do is just split them in half. So, and half of 36 is 18. And then same here, we could do 24 over 18. Well, let's split them again because there still can go. So that's 2x over 9. And here that's 12 over 9 as well. Can I reduce anymore? I sure can. For this one, I can make it. I'm going to just shift on my paper. So now we know that 12 over 9, I'll reduce this here. 12 and 9 both go into 3, so that will be 4/3. And that is improper, but we're just, for tonight, we're just going to leave our fractions the way they are. So y would equal 2/9 x minus 4/3 as your y-intercept. And so that would roughly actually be like 1.3 for your y-intercept if you graph that. Oh, I like the suggestion. I do. We could make it a specific grade if that's what you all would like. That's something we can think of. Okay, now it was also asked for us to do a point slope. Well, a point, yeah, with 2 points, right? I'm going back. One that I see as is giving 2 points, create an equation of the line. Okay. And let me get us a problem real quick. All righty. So let's do this. All right, so if we are given 3, 4, and we are given 5, 8 as 2 points on the line, we are going to create an equation of the line. All righty, so when we have 2 points and we're trying to figure out where to go from here, we first want to start with our slope. So our slope equation is that y2 minus y1 over x2 minus x1 is equal to our slope. Because if we don't know anything else or where to start, we do know we have 2 points. So we're going to label our points x1, y1, and it doesn't matter. They're interchangeable. It's just whatever if you call this one 2, then the x has to be 2. If you call this one 1, the x has to be 1. And I wrote that backwards because I was talking. All right, so now we're going to plug in our numbers. So over here, we're going to have 8 minus 4 over 5 minus 3. And we're going to solve. So we get 4 over 2, which is equal to 2. So now we have our slope. And so we can use the point slope equation that says y minus y1 is equal to m times x minus x1, so that we can find the equation of our line. And because we use both points to find our slope, you can use either point to plug into this equation. It's very interesting that I still remember all of these equations by heart. Okay, so I'm just going to use our 3, 4. So y minus 4 is equal to 2 times x minus 3. Alrighty, and now thinking of our order of operations, we are going to distribute this 2. And if you notice it, it's already going to be starting to look like our y equals mx plus b, like we wanted. So we get 2x minus 6 is equal to y minus 4. And just like we do in regular equations, we have to move this 4 over so that we can completely get it into our y equals mx plus b form. So we're going to add 4 to both sides. And so we will get y equals 2x minus 2 as our answer. And this is how you go from 2 points to your y equals mx plus b equation. Any questions in the chat? Can we do something with an inequality? We absolutely can. Let's see here. All righty. So we solve inequalities just like we solve equations, except the inequality sign sometimes has to flip or change based on if we are multiplying or dividing by a negative number, because we just want to make sure that our inequality is true. So I am going to start with let's just do this. Negative 5u minus 19 is greater than or less than negative 6 plus 2u. Alrighty, so again, like I said before, we want to start off with treating this like a equation. So the first thing we're going to do, we want to distribute this 5. So we'll get a negative 5u minus, that's 5, carry my 4, negative 95. And that is greater than or less than negative 6 plus 2u. Alrighty, so you might have seen our video on it. Don't call mama after midnight. We are going to follow those steps, and they can be found in our algebra strategy guide. So we want to combine like terms. So we are going to combine this negative 5u and 2u, and I'm just going to bring this 2 to the other side. So we'll get a negative 7u, and minus 95 is greater than or equal to negative 6. And so we are going to add 95 to both sides, and we're going to get negative 7u is less than or equal to 89. 89. Alrighty, So now our final step, because we want u by itself, we are going to divide by 7. Oh, I actually see something. I see something. Does anybody know what I did as I was moving too quickly on this problem? And I just caught it myself. Drop it in the chat because this is very important. And it's great to see it in real time, how when we're moving a little fast. Check the distribution. Yes, I distributed this -5, and a negative times a negative, our friend should have been positive here. Yes. And yes, because the negative times a negative is positive. So that actually changes everything that I did down here. So now we're actually going to add this 95 and 6 together. So we will get 107. And I'm just going to cross that out, 107. All righty. And now this is the part where inequalities flip. So if you have a negative and you're going to divide or you're going to multiply, you're going to flip it. And why? Why do we flip it? Because then the equation will not be true if we do not flip the sign. So when you plug in numbers and things, it won't equal. So since we are going to divide this by -7 on both sides, this is going to flip. So now u is greater than or equal to -107 over 7 as our answer. And so inequalities are just like solving equations. The only thing that changes is if you divide or multiply by a negative, you flip the sign. Would you all like me to do one more? Let me know in the chat. Or if you would like to see something else tonight. Kim, do we have any other requests tonight in the chat? Yes, please, you would like to see one more. All right. Awesome. All righty, let's do okay. Let's do another like distribution. 3 minus 2 times n minus 4 is less than -1. Alrighty, so we are going to distribute again, and this time we are not going to leave our minus behind. So we are going to distribute this -2 to each one. And if you notice, we're still kind of following our order of operation rules since we are dealing with our parentheses first. That's why we're going to distribute this first here. So we will have 3 and now minus 2n and plus 8 is greater than -1. And then we're going to combine our like terms on this side. So we'll have -2n plus 11 is greater than -1. And then we are going to subtract our 11 from both sides. So we get -2n is greater than -12. And then we are going to divide both sides by our -2. And we said in our last problem, when we divide, we flip our sign. So we will get n is less than 6. And because we have negatives, those cancel out. Alrighty. So just like solving equations. Yes, when you divide, flip the inequality sign. Alrighty, let's see, where do we want to go from here tonight? I was going to work a 6th grade problem. Oh, you're welcome. You're welcome. I hope you all are enjoying it tonight. Let me see. Let's see that strategy guide and math. Oh, you you are speaking my language right now. So I was actually going to work a problem from our math bites next for 6th grade. We have them for 6th, 7th, and 8th. They are Texas aligned. And since tonight we were talking so much about y-intercept and y-mx plus b and all of those things, 6th grade is where we really start, and in middle school talking about those things. So I was going to grab a problem for here, just for us to look at together tonight. And then we also have our strategy guide that we have. And as you can see, it has strategies. So like things we talk about here, GEMDOS, and these are available for purchase. We're all about strategies around here and just ways to think about math. And since we've been doing so much talking about equations today, this actually breaks down the equation. What is a variable? Our x. What is a coefficient? And that's the number in front of your variable. And these are considered our constants if we really want to talk about our vocabulary. And then it just shows you some of the steps that you need to do to solve those equations. So really great things for our students. We're always creating what you need. And we would just love to hear about, what do you need? What do you want to see work? What would be helpful for you to make this math make sense, because that's what it's really all about, for sure. So let's jump into one of our problems here. And I'm gonna write in this. Hopefully y'all can see it kind of well. I don't know. Oops. Okay, I'm doing too much. But okay, yeah. All right. Right there. Mrs. Daniel asked her math class to come up with an equation that could describe the relationship between all the values X and Y in the table. Alrighty, so we see that when X was 3, we had 15, and then when X turns 4, we have 20. So we're looking for the difference from getting from 15 to 20, then we go 20 to 25, 25 to 30. We see that there's absolutely a difference of 5 here. And then we want an equation. So we know that 5 times 3 gives us 15. 5 times 4 gives us 20. 5 times 5 gives us 25. And whether we went to 7, it would give us 35, which would be next in our pattern. So our equation is y equals 5x. So this is how we're using a table to find a simple equation. And I'm going to do this one as well. Hopefully you can see it. I know in one of our last problems, somebody asked, what does that 1/3 do? Or what is, basically they were asking, what is y-intercept? And what y-intercept is, if you can see this graph here, it's the point on the line when x is 0, but y is on that y-intercept itself. So this is y, and it's intercepting, meaning it's crossing, penetrating, touching the y-axis here. And so even just looking at this graph, we know that our y-intercept is 3.5. And then we also could use the graph to find our m, our slope. Like we said before, we're rising and running. So we're running and rising, running and rising. Well, we know that's 1 to 1. So our equation would be y equals x plus 3.5. And yes, this one here has the answers throughout, but the ones that you will practice will not. But that is how we use our graph to determine our slope and our y-intercept. So just how we did it numerically today, we can absolutely also do it graphically for sure as well. And these are just great things that you can practice for yourself, with your students, and the building blocks to the harder algebra and algebra 2 that some of you are tackling today, for sure. This is another really good one, and then this will be the last one I do with y'all on here or in this book tonight. Which graph best represents the relationship between x and y in y equals x over 3.5? One thing I want you all to notice, we know that our equation is y equals mx plus b. Well, right now we don't have anything adding to our x or our plus b, right? So since we don't have anything adding to it, what do you think that means our b is? Any guesses in the chat? It will be 0. So that means our y-intercept is 0, which, as you can see, b is 0 and a is 0, but c is not 0. So we actually can cancel that 0 for sure. All righty. Then we are going to look at, so we're out of A and B. And so what is our M here? Since our x is over, our m is really 1 because there's always an imaginary 1 in front of that x. It's 1 over 3.5. So what we're really doing here, we're rising 1 and we're running 3.5. So we're moving over 3.5 from where we're rising. So we're going to try that out. We're going to rise 1 and we're going to move over 1, 2, 3, and 0.5 is just like half. So we should end up somewhere like that from that point. Well, we don't, so it can't be B. So let's look at A. We're going to rise 1, and then we're going to go over 1, 2, 3, and a little half up. It has to be A. So this is how you use that y equals mx plus b for graphing, just like we did when we actually did the algebra problems. All righty. Well, thank you for joining us tonight for Work It Out Wednesday. We appreciate you all being here. We are Math-A-Matics Tutoring, and we are your partner in all of your tutoring needs. We support K through college students each and every day. There is a team of us. We are lovers of math, as you can see. Please tell your friends, tell your families that we are working out problems for free on Wednesdays. We are on Instagram, Facebook, TikTok. We do strategies and math problems, hacks, and tricks on our socials, and we can't wait to see you and interact with you. Today was a little later than what we usually do. We usually do Work It Out Wednesdays at 7 p.m. on Wednesday nights, but we will be back at our regularly scheduled time next week, and we hope to see you then. All righty, have a great evening, and we will see you next time.